Yeah, yeah, if I was looking at all that, it's actually.
Like I'm like,
These are couple wars. Yeah, I looked on some of regular shower.
Disdain from my.
I'm like, $5 water for me, it's not me, I don't like everything.
Yeah. All right, so hopefully you guys are at a point where you're either finishing up or getting close to finish with packet 5. But I also have keys for packets 5 and 6. If you're wanting to use this class period to finish up packet 5, that's fine. You can take up packet 5. I'm just going to kind of go through problems in packet 6. So each day, I'm just going to kind of highlight certain problems, and then if you can stay on this pace, then you should be able to finish packet 6 by Friday. But if not, it's okay. You still have a couple more weeks. But ideally, you see everything by Friday or by this weekend, and that way you can take full advantage of seeing as many problems as you can for the weekend. Okay, any questions about our schedule for this week? Is anyone missing packet 6? All right, so go ahead and start with number 1. I'm just going to put the key up here, but you can also pick up the key if you're working on a different set of pages if you've already done those. After a minute or two, I will go through each problem. So number 1, we know that the condition for alternating series test is if I can just show that the limit of my expression without the alternator, if it goes to 0, then that's all I need for my series to converge. So we definitely see that's the case. If I were to put absolute value around it, we know that 1/n to the 1/3 does go to 0. But if we were to somehow strip away the alternator, it would fail the p-series test, right? Because p-series says my p-value in my denominator has to be greater than 1 in order for my series to converge. So without the alternator, it would diverge, but with the alternator, it converges, and so therefore that fits conditional convergence. For number two, for what value is my series conditionally convergent? So conditional convergence again is a scenario where if I have 1/n to the p and my p-value is between 0 and 1, right? Anything greater than 1, it'll all of a sudden converge. But that would be for the larger scenario. But in this case, looks like it's n/n to the p. So in order for me to get this to be conditionally convergent, I would have to basically, when these cancel out, I would need this to be left with between 0 and 1. So now my p-value has to be between 1 and 2, because if I were to plug in 1, this would fall under the condition. Oh, sorry, greater than 1. Imagine this is 1.1. If I have 1.1, this being 1.1 and 1, this will reduce to be just 0.1, and 0.1 falls under this category. And if I plug 2 in, n to the first power divided by n to the second power is basically 1/n to the first power. So we're just basically shifting everything up 1 degree because there's a n that we can use to cancel out to make it fall under this category. For number 3, which is the following, is conditional convergence. If we look at answer choice C is basically if we were to do limit comparison test, or if we're trying to find a comparison partner, it would be 1/square root of n. If we cancel out the root n, and so 1/square root of n is 1/n to the 1/2, and that falls into that category of on its own, it would not converge, but it does pass the limit as n approaches infinity. It does go to 0, and with the alternator, it's enough to converge. But without the alternator, it would basically fail the p-series test. Number 4, the alternating series test can be used to show conversion for which of the following. So remember, even though for our application purposes, most of our problems have been just testing to see if the limit of the absolute value of a sub n goes to 0. If it does, then we know it passed that AST. But technically, it needs to also meet the second criteria, which is a sub n plus 1 has to be less than or equal to a sub n. Every subsequent term has to be less than the previous one, at least the absolute value of it. And most of our problems, we never had to worry about passing this one and not the other one. But this one, these piecewise functions, we kind of have to look at each term to see, okay, is every term decreasing? And if it's not, then it doesn't meet the criteria for AST. So only answer choice 1 is allowing for every single term to be less than the previous one. For number 5, we see the limits of my a sub n does not, does go to 0. Every term is decreasing. So D is the only one that is true. And number 6, we're supposed to look at the graph and understand, okay, if every single term is not decreasing, then it doesn't meet the condition for AST. So if we look at the graph and tell that, okay, it's not always decreasing, rises and falls, and ultimately it's going to fail for AST. So we know f prime is 1/1 plus x to the 7. This is perfectly set up for us to do power series. Because we know f prime is just really a sub 1/1 minus r. And if my a sub 1 is 1, and if my common ratio is negative x to the 7th, I can build my f prime as a polynomial. If I can build out my first few terms of f prime, I can just take the antiderivative of this and reach the polynomial version of my f of x. So the goal is recognizing, oh, this is a power series. I can just use geometric series test or geometric series form to build out my first few terms. And then once I get my polynomial version of f prime, I can take the antiderivative and have a much easier time getting to f of x because it's just a bunch of power rule. Okay, let's look at number 8. Number 9, we have a Maclaurin, series for cosine of x. We have a Maclaurin, series for 1/1 minus x. So if I can get the polynomial versions of both of them, I can just multiply them together to get what would be my first few terms.
Yeah, I think I already asked you this, but I was just going to ask on the AP exam, if on like an FRQ, a question shows up and you have to use like the Maclaurin series of e to the x, for example, because we memorized those,
Yeah.
can we just write those out?
You should be, yeah, you should write those out. You should not, try to build it out from scratch.
Okay.
Yeah. Yeah.
If they give you e to the x and it's Maclaurin, they're trying to get you to go through that shortcut method.
Okay.
Could also expand it from scratch. It would just take a lot longer and wouldn't be as efficient. Okay, any questions with 8 or 9? Try number 10. Okay, 11. Let me know if you have any questions as we're kind of working through these Taylor series polynomial. Anybody still need to look at 11?
Okay, 13, we know that, we're trying to figure out that first unused term that will produce that error bound. But this is, with the calculator, so we can just, set up that n plus first term. So they say to use, k, but you can use n as well, but I'm just setting it up where 1 over k plus 1 or 1 over n plus 1 squared, that will be I want the first unused term to produce less than 9/10,000, so I'm just algebraically using my calculator and solving for k. Sorry, greater than 33, equal to 33, not 3. Answer choice C. Fourteen, we know the first unused term will be what n is 16. Since we're starting at n equals 1, so we know the 16th term is when n equals 16. 15 is just recounting the definition for alternating series error bound.
Sixteen got split between two pages there. Build your degree 4 Taylor polynomial. Sorry, yeah, if we build a 4-degree Taylor polynomial, then you know that the fourth term is going to give you the error bound of that degree 3 Taylor polynomial.
Without even looking at the problem, you look at all these maximum of some random derivative. That's an indication that it's going to be Lagrange error bound, right? They give you some maximum of some random derivative. It's going to be error bound involving a Lagrange. But they're testing us to see if we can pick the correct value. If we were trying to determine the error bound of the fifth degree polynomial, we know we're going to be trying to find involving the maximum of the sixth derivative. So the 58.8 is one that we use. The other ones are not going to be useful for our answer.
$19, interval of convergence. So go through ratio test.
Let's start with ratio test a sub n plus 1 divided by a sub n. Limits of that is less than 1. And I clean everything up and I'm able to get all the way down to absolute value of x minus 2 is less than 5. Put it together, I get x between -3 and 7, so I gotta test the -3 and 7 with my general term. And 3 diverges, -3 diverges, +7 converges, so answer choice B.
Number 20, if we understand that cosine x can be expanded out to 1 minus x squared over 2 factorial plus x over 4 factorial, we can put it together with the 1 plus x squared and clean it up to make it match answer choice A.
The 21 is a little bit more challenging. I think what we need to be able to see is, oh, this is basically looking like a slightly adjusted version of sine of x. So what if we just start with sine of x and make a slight adjustment to fit it into this series that they want us to find the sum for? So you can think of the pi over 2 as my x, right? So it's almost the same thing. 2n plus 1 factorial, that's the same. -1 to the n, that's the same. But it's missing that +1 here. So if I can find the sum of the series using sine, I know I just have to multiply or divide by this pi over 2, which is the same thing as multiplying by 2 over pi, to get this to turn into this. This divided by pi over 2, the same thing as this. So if I can start off with something that I know, I can find the sum for that, and then just make a slight adjustment into this sum that they're asking. But that's stuff, looking to see, oh, this is, they want us to use sine, series to get to our answer here. Number 22, we can build our Maclaurin series of e to the x, adapt it into e to the negative x, and then distribute the 1 plus x through to make it match one of our choices.
After we apply ratio test, we see that the x in the numerator doesn't cancel out, so it goes out to infinity, which means that the series only converges at the center. Everywhere else it'll diverge.
Okay, so, got through a good, chunk of the pages, so hopefully tonight you can, do some more of the pages. I think pages 10 through 15 are mostly the Graham Darabont and, alternate series Darabont, so, hopefully you can work through those pages, but we can go over any problems that you have, tomorrow, but we're just gonna work through our pages. After pages 1 to 15, 16 to 30 is a full, BC test, so there'd be a mixture of, A, B, and BC concepts there. But here, the first 15 pages, we're just focusing mainly just on, infinite series. Help sessions, if you have any questions about packet 5 or 6, I'll go over any FRQs. Help sessions for BC will be, in the morning, Tuesday and Wednesday. And then Thursday, Friday, I'm reserving it for AV student. If you have questions, you can come by Thursday and Friday as well. There's no, ask any questions that you want, but it's just giving a, priority to AV students if they have questions. If there's a lot of having questions, I will say Friday. Okay, come get your phones. So what's your timeline? You're trying to get through all the packets by this week? Judging on how much points it gives me the test.
I have a chemistry quiz today too. Like, I was just wondering. And I don't really understand anything. Really gonna have this quiz. I'm like, I can just make that. True. Yeah.